Hi again, everyone. I'd like to welcome you back to my YouTube channel. So, if you're new to this channel, I'm Andrew Commander and I make educational videos on the CAPS curriculum. And this video serves to provide you with the basics that I think are very important when you really want to understand climatology. Climatology can be a very confusing subject, rather topic, and so you need the necessary foundation. Okay, so this video will help you understand climatology better. Okay, the terms that we use in climatology, and all the aerodynamics that you need to know when it comes to MSs, when it comes to pressure, high pressure, low pressure, and all of that. Okay, so I'll start right here with this illustration, as you can see here. So we talk a lot about atmospheric pressure, right? So you find that we have anticyclones, cyclones, low pressure, high pressure, and the related weather patterns as well. And so it's really important that you first understand what atmospheric pressure is and how does it influence the movement of air, and how is it also related to uh, weather patterns, as I said. Okay, so pressure is defined. Okay, so it's defined. So as you can see, pressure is defined, of course, as the amount of force exerted at a particular surface area. Okay, or you can say an amount of force per unit area. Okay, and so we consider, that means that pressure considers two elements. Okay, it's the force and also the surface area that, of course, this object is passing over. Okay, so I have two examples here. I have a stone on the left and the leaf on the right. Okay, and the question that I would ask you is which object, okay, which object between these two applies more pressure to the ground? Which object would you say applies more pressure to the ground? Okay, and I'm sure that most of you would definitely say that it is the stone. Okay, why? Because, well, it is heavy. Okay, but of course that doesn't serve the full explanation, or maybe rather a better explanation of that. And so here we have two objects, and let's say that these two objects occupy the same surface area. So they occupy the same surface area. So from there to there, let's say it's the same as from there to there. Okay, right. So that means that we've kept this area, the surface area, constant. Okay, so surface area is constant, and so what will dictate whether um, each one of these applies a higher pressure or a lower pressure will be the force. Okay, so of course the force also takes into consideration the mass of a particular object. Okay, so for these two objects, you can definitely see that the stone, you know that the stone is made up of uh, uh, tightly stacked material. So when it is tightly stacked, then we say that it is dense. Okay, it's made up of these many particles that are close together, and it makes the whole stone to be heavy, okay, and dense. Okay, so this is heavy and dense. Well, when we compare that to the leaves, of course, these are light, okay, and of course, they are less dense. Okay, right. So now, which one of these would apply a greater force onto the ground? Okay, so of course, guys, it has to be the stone. Okay, so the stone, because it is heavy and dense, it applies a lot of force onto the ground. So if it applies a lot of force onto the ground, remember that we've kept these the surface area of both of these objects, we've kept it constant. So now it only depends on the force. So when it comes to the leaves are light, they are less dense, so they do not really press a lot against the ground, okay, because they have a little pressure, okay, so, I mean a little mass and hence a little force, okay, and so they exert a low force and hence therefore they also result in a low pressure. Okay, so because this stone exerts a greater force, it therefore, because it is heavy, it applies a greater force and hence a greater pressure. Okay, so we say that there's a high pressure that is created on the ground. Okay, so that what this means is basically saying that um, whatever object this is, it's pressing against the ground with higher force, right? Compare that to this leaf, which is pressing against the ground with very little force. So relatively, the leaves actually create an area of low pressure, okay, on the ground. Okay, so because they apply low pressure, because they have a smaller mass and hence a smaller force that they exert onto the ground. Okay, so so now we know that if an object is less dense, then it's going to is associated with a low pressure, or is going to put a low pressure on the ground. Okay. Whereas if an object is heavy and dense, because it is heavy and dense, it exerts a greater force onto the ground, and hence it applies a higher pressure onto the ground. Okay. So that's the basic idea about atmospheric pressure. Okay. Now, of course, we do not talk about stones and leaves when it comes to climatology. We talk about air, guys. Okay. So whether it's cold air or warm air. Okay. So let's talk about cold air. Okay. So cold air in nature, okay, we know that it is heavy. Okay. So cold air is heavy in nature, and it is dense as well. Okay, it's heavy, it is dense. Okay, and it likes to sit on the ground. Okay, it doesn't like to rise up or anything. It likes to remain on the ground. Okay, every time. Whereas warm air, its properties, it is of course light. Okay, and of course it is less dense. Okay, so now which one of these will apply a greater force on the ground? Okay, now let's start with the cold air. Now the cold air, as we know that it is heavy, it is dense, so it presses against the ground and applying a greater force because it has a greater mass. It is heavy, guys, in nature, and so that means that it's going to press against the ground with a greater force. Okay, and so that means that the ground will experience a higher pressure. Okay, a higher pressure, guys. Okay, or we say that an area of high pressure is created on the ground. Okay, it's always relative to the ground. Okay, at grade 12. Okay, it's always relative to the ground. So an area of high pressure will always be created by cold air. It's always associated with cold air, guys, each and every time. Okay. Now, looking at warm air is light. Okay, it is less dense, and warm air likes to rise up. Okay, so what happens, guys, is that warm air before warm air is created. Okay, so when it's a sunny day, right, um, the sun hits the ground, right, so the ground warms up, right, and then the ground, what it does is that it transfers that heat energy, okay, to the surrounding air. Okay, the air that is right above it. Okay, and so that means that that particular air now will, or that particular MS will warm up. Okay, so it will warm up, and so it will become warm air, right? So when it becomes warm air, it changes that heat energy that it was transferred. Okay, so we say that this ground transfers this heat energy via a heat transfer that we call conduction. Okay, so conduction is basically the heat transfer by contact. Okay, so for an example, when you have a stove, okay, let's say that's your stove, and this is your pot over there. Okay, so so what happens is that the stove heats up, and it transfers that heat energy onto or into that pot via conduction. So it's by touch. Okay, so that's what happens. That's how the ground heats up the air right above it. And so now that air has heat energy transferred to it, it's going to change that heat energy. Okay, change that heat energy uh, and change it into kinetic energy. Okay, so it changes that into kinetic energy. Now kinetic energy is movement energy. Okay, it allows you to have energy to move. So now the warm air has energy to move. So what does it do? It rises up. Okay, there's nowhere else it can go, and cannot go through the ground. So what does it do? It rises up. Okay, so warm air tends to rise up, guys. Okay, because of this kinetic energy, of course. Okay, whereas with cold air doesn't have much of that kinetic energy, and so that's why it prefers to press against the ground. Okay, it does not have that kinetic energy, that movement energy to move up. Okay, so we're saying that warm air rises up. So that's another thing, is that cold air actually sinks down. So it likes to sink down. Okay, so that's the word we should have used there. Sinks down, or you can say that it descends. Okay, so let me rather use that word. Okay, it descends. Okay, right. So whereas warm air rises up. Okay, so warm air, it rises. Okay, so if it rises, guys, how much force is it exerting? Is it exerting onto the ground? Okay, how much force is it exerting there if it is rising up? It's little force, right? It's little, because it is rising up, right? And so now this then creates an area of low pressure, because it, of course, applies a very little force and hence very little pressure onto the ground. So we also say that an area of low pressure is created onto the ground. So that's how it is created, guys. You have to start from the start from the start like that, from the sun, and head on like that. Okay, so and then yes, we'll talk about the weather after that. So that's the basic idea. Say that low pressure will always be associated with warm air. Okay, because warm air rises, and hence it leaves, or it applies a little pressure onto the ground, and hence an area of low pressure is created. Okay, whereas cold air is heavy, is dense, it sinks down, it presses against the ground, and it has a greater mass, and hence it applies a greater force, or and hence a greater pressure onto the ground. Okay, so we should ensure that we know that warm air is always associated with low pressure, and cold air is always associated with an area of high pressure. Okay, so now the weather systems that you learn about in grade 12, your mid-latitude cyclone, your tropical cyclones, this is what is happening there in that system. Okay, that's what is created that huge system that you see. It started here. Okay, whereas your anticyclones, your Kalaharis, your South Indian and South Atlantic, those are of course they have cold air masses that of course sink down. Okay, and hence they are called anticyclones. So an area of high pressure, okay, is also called an anti-cyclone. Okay, so it's nothing much, guys. Whereas an area of low pressure is called a cyclone. Okay, right? So this is where everything begins. Okay, that's why I decided to do this video. It's where everything begins, and we build on from there, of course. Now let's take a look at more details about these systems. Okay, saying that we have a cyclone or a low pressure system, and we have a anticyclone or high pressure system like that. Okay, so this is not all. Okay, so first of all, um, this cold air, yes, it creates an area of high pressure. Good, that's fine. But does it go? Do you think that it goes through the ground? Okay, when it is sinking down? No, of course not. Okay, it does not go through the ground, guys. It cannot just go through the ground. So what happens is that, of course, because it is heavy, yes, it sinks down. Okay, sinks down towards the ground, but of course, it doesn't go through the ground. But what does it do? It separates there. Okay, it separates. It moves to different positions, or rather different areas. Okay, like that. So it spreads. And so I like to rather use um, this word, okay, say that it diverges. Okay, that is to move, to separate areas like that. Okay, so if I were to be looking at this from the top like that, I would see something like this. Okay, it is actually spreading. Okay, it's moving to different directions, so it is moving into this page. Yes, it is descending, but then when it reaches the surface, it diverges, move to different areas like that. It spreads, separates. Okay, so it diverges, right? Now we have this principle that we have that is very important in climatology. We say that um, air, okay, so air always moves, okay, from an area of high pressure to an area of low pressure. Okay, so we know that if there's maybe an area of low pressure there, an area of high pressure there, an area of high pressure there, okay, then of course air will move from here towards there. Okay, move from here towards there. Okay, so it's always looking for the most or for the lowest pressure that it can find. Okay, and so if you are standing somewhere here, you will feel that you feel moving air, which is what we call wind. Wind is just moving air. So wind basically forms because air is moving from an area of high pressure towards an area of low pressure. Okay, so now saying that, okay, an area of high pressure should be created um, when this cold air sinks towards the ground, right? So it moves from this area of high, so air diverges, moving from this area of high pressure, moving towards areas of lower pressures. Okay, so and so that is what is happening there. Okay, and then when it comes to the warm air, so we say that warm air is actually rising up. So if it is rising up, it is actually leaving an area of low pressure to the ground. So what happens? Relatively higher pressure areas will want to move towards that low pressure, right? So air from higher pressure areas or relatively higher pressure areas, we want to fill that space there, okay? Or what we say that they converge there, they meet there at that area of low pressure, okay? So this is what happens. And so when this air rises up, okay, it will condense, form clouds, and it will diverge at the top, okay? So this is what we call upper divergence, okay? So it diverges at the top, it converges at the surface. So this is what we call surface divergence. So you need to know these terms, guys, okay? So this is upper divergence and surface convergence. And then it sinks down again. And so as you can see that this forms sort of a circulation, which is what we call a cell, okay? Cell, that circulation. This is what you see when it comes to a low pressure cell, okay? Of course, a high pressure cell, there's a surface divergence, okay, and then they separate like that, and then at some point they meet up with other MSs from other relatively higher pressures, and so they do what? They converge, they meet up there. And what else do? They rise up. They cannot go through each other, but they rather rise up, okay, and then diverge there at the top, okay. So upper divergence, there's uh, upper divergence and there's surface convergence here, as you can see. So it's very important that you know what happens here, okay. So let's then take a look at these properties here. So we have a low pressure cell on the left, which is what we also call a cyclone, and then a high pressure cell on the right. So we'll start with the low pressure cell that is on your left. So so low pressure cell, of course, is associated with warm air. Okay, so low pressure is always, as I said, associated with warm air, right? So it's also formed after warm air has risen. Okay, remember, guys, that you cannot form a low pressure if warm air hasn't risen. You have to first the warm air has to first ascend. Okay, you also use that term. It has to ascend first. Okay, once the warm air has ascended, now you then create this area of low pressure. Okay. So air converges towards the center of the low pressure. We have already mentioned that. So once this warm air has risen up, more air gets invited um, to fill up that gap, okay, to fill up that space, okay. So it moves towards that center, towards that low pressure, okay, from relatively higher pressure areas. Right. We also see that condensation occurs. Okay, so I'm sure you guys do know that condensation. This is a phase change from, of course, from air. Okay, so we're changing phases from air all the way to liquid. Okay, so that is what we call condensation, and you see it every day when you actually using the kettle. So your kettle, what it does is that when the water is boiling, okay, so the water escapes as gas, okay, so as it escapes as gas, once it hits a surface, okay, a medium, so this gas, this hot, moist air, okay, so this air that comes from the kettle is warm, okay, and it's also moist, okay. By moist, guys, we mean that it has a lot of water vapor content, okay. So it has a lot of water vapor in gas form, okay. Remember, air is made up of a lot of gases, but if it has a lot of water vapor in it, then it becomes very light, and so it's easy for it to rise up, and it's easy for it to form clouds, turn into rainfall. So air can be warm, but if it is dry, then condensation will not occur. You will not see clouds. you will not see precipitation, rainfall. Okay, so warm moist air, when it rises up, so as this warm air rises up, it then cools down. So it starts to cool down, and cool down, and then of course it start then to form clouds. Okay, so it condenses and forms clouds. Okay, and then when there's sufficient water particles inside of these clouds. Remember, clouds are made up of water particles, and so when there is sufficient enough water particles, then they start falling down. Okay, so that's what happens even when you're using a kettle. So when um, this warm moist air rises up, once it hits a surface that is cold, of course, relatively cold, and so that means that its temperature actually drops, such as the illustration on the bottom left. So once it hits that, then you start seeing droplets. Okay, so it already has condensed. So we already see that condensation is okay. So a low pressure cell is always going to be associated with condensation. Okay, only if, of course, that air is warm and moist, right? So we say that it is unstable. So by unstable, guys, we mean that air is actually rising up. Okay. Okay. So that is unstable. Okay. And so air moves in a clockwise rotation. So for all the cyclones, the mid-latitude cyclone, the tropical cyclones, all the cyclones, which of course are low pressure cells, you have air that is moving in a clockwise direction. And you see this, of course, if you are looking at this from the top. Okay, so you have to look at this circulation from the top, and you would see that, okay, air is indeed moving in a clockwise direction. So it's like clock, how of course clock works. Okay, and then these are isobars, by the way. So isobars, of course, you guys do know that they basically join areas of equal pressure. Okay, equal atmospheric pressure. So, for an example, for each area that is in this particular each area in this particular isobar has the same um, isobar value. Okay, we measure isobar values, of course, in hectopascals, which of course are also equivalent to millibars. Okay, so we're saying that for or in a cyclone or a low pressure cell, you have isobaric values that are decreasing towards the center. So as you move towards the center, the isobar values decrease. So let's say it's the isobar on the outer part of this is 1,000 hectopascals, and then this is 900 hectopascals, and then this is 800 hectopascals. Okay, so as you can see that the pressure is actually or the isobaric values are actually decreasing towards the center. Okay, so the pressure is decreasing towards the center. As you move towards the center, it is decreasing. Okay, so that's how you would see that, okay, this is indeed a cyclone. Okay, that's one of the clues that you would use, of course, and of course the LP or the letter L that you would see um, in a synoptic weather map. Right, and also we have this type of energy that is released, which we call the latent heat. So as this air condenses into clouds, okay, as you change from one phase to another phase, there's energy released, okay, and that energy, of course, we call it latent heat. So it basically acts as a fuel to support this constant circulation that we see here, okay, because we said that's going to be upper divergence, and then they will sink, and then they will converge at the surface again, so on and so on. So it favors this rotation so that it keeps on going, so that it keeps on circulating the way it is. So latent heat it basically acts as a fuel to these systems. Okay, I think I must have made a mistake somewhere here. So here it should have been upper convergence, right? Upper convergence, and then at the bottom, of course, it's surface divergence. Okay, right, yeah, that's what I forgot to write down. All right, so examples of these, of course, are your coastal lows, your mid-latitude cyclone, your tropical cyclone, your thermal low. All of these have these type of air movement. They have all these characteristics that we see here, all of them. Okay, and so of course you would find that there's a low pressure, and of course you see. I'm trying to draw um, uh, uh, a clockwise movement of air. So as they are rising up, as this air is rising up, it rises up. It rises up, of course, in circles like that. Okay, because of a force that we call Coriolis force. Okay, we'll talk about all of these in the following lessons that we'll have. Okay, this is the first lesson of our series. It's a lot more videos that we're going to do. So this is your cyclones, guys. This is what's happening there. This is all the air movements, all the pressure, um, all the dynamics of these cyclones. This is what happens there. Okay. Whereas when it comes to anticyclones, it's actually the opposite. Okay. So we know that an anticyclone, of course, is associated with cold air. Air diverges at the center, we know that. So as air descends, it then diverges at the bottom, so at the surface. And there's no condensation that occurs, guys, because remember, for condensation to occur, you have to have air, warm air rising up. Okay, draw that again. To have warm air rising up, and then what happens? Then it has to cool down, right? So as it cools down, then you start forming clouds. Okay, so that's when condensation occurs. But with anticyclones, you have cold air descending or sinking down, and as it descends down, guys, it actually warms up. Okay, so the opposite actually occurs. It warms up, and we say that it does so adiabatically. Okay, so it warms up adiabatically. Okay, um, so so you cannot have any condensation. Okay, like that. So because you have to have warm air that's actually becoming cold air, not cold air that's becoming warm air. Right, so there's no condensation. That means clear skies. Okay, clear skies, calm conditions, no clouds, guys, and it's just calm, stable. Okay, stable. There's no rising air. So that's why anticyclones are associated with stable weather. Okay, and no condensation, no rainfall. Okay, and we also see that the air actually moves anti-clockwise. Okay, so um, while the air in cyclones moves clockwise, this air in anticyclones move um, anti-clockwise. Okay, oh, that's actually clockwise. So anti-clockwise should be opposite like that. So as you can see here, we have an anti-clockwise rotation of air. Okay, and so that's one of the other signs that you should also look at. Okay, and of course there's high pressure at the center there. So we also see that as we are moving towards the center there, the pressure actually increases. Okay, isobar values increase. Okay, so if this is 1,000 hectopascals, then the following could be 1100 hectopascals. Okay, and the next one, of course, towards the center could be 1200 hectopascals. Okay, so and you need to note, guys, that we count using the same interval, the same increment. Okay, so that's what we call the isobaric interval. Okay, if you look at this, if you look at this isobars or this anticyclone, you can see that okay, the pressure is increasing by increments of 100. Okay, so you basically just take one isobar and the next isobar, and you look at the difference there. So 1100 subtract 1000, so that of course is 100 hectopascal. So I'm just that's another term that we use, of course, when we are looking at isobars. Okay, isobaric interval, that's the difference between consecutive isobaric values or isobars. So examples of these include the South Indian High, the South Atlantic High, and the Kalahari High. So all of these are anticyclones, and we see this type of circulation or this type of rotation, which is anticlockwise. We see that the air actually increases going from um, um, the air pressure increases going towards the center. Okay, and so air here should be actually moving outwards. Okay, remember this is a high pressure, so we know that air moves away from high pressure towards a low pressure, right? So it should be moving outwards, circulating but moving outwards. Okay, so that is how we should go. Whereas here it should be moving inwards. Okay, so air should be moving inwards like that, but of course in circles like that. Okay, moving inwards and clockwise. Right. So guys, this is the basics that you really require in order to understand what we are about to do. Because in the next videos we'll be starting our journey on climatology. Of course, we start with mid-latitude cyclones and go on to tropical cyclones, anticyclones, so on and so on. So you need to understand all of these laws, and because I won't be going through them again. Okay, so I really hope that you will view this video in our series. Okay, so I will see you in the next video. Please let others know, as it will benefit a lot of people.